Hello everyone. So today, this is going to be the 14th lecture of the series Generative Deep Learning, and we are learning about the GAN. GAN is what it is used for. It is used for generating the image and different type of things. We'll be seeing it. We are working on the BRICS dataset, and in the BRICS dataset, in the previous videos, I have discussed about what is the big dataset and which type of images are there in the dataset. And today we are going to see about the discriminator. Okay, this is I will say that this is something that I am learning, and together you can learn. Let's go on the right. Yeah. In the previous video, we have discussed about that original data was scaled in the range of -1 to 1, and we had pre-processed our data. Okay. So, if you want to see the meaning of each and every line of code, then you can just go on the chat GPT, okay, and just paste it here and just write it, teach me this code. So you'll be getting each and every thing that what it is actually doing, so that you will have the more clarity of the what the code you are writing. Now let's talk about the discriminator. In the previous videos, we have talked about the discriminator. Like discriminator is someone which discriminates that is it fake or it is real, something like that. Okay, so let's see. The goal of the discriminator is to predict that if an image is real or fake. That is the very simple thing. Okay, so it is supervised image class. So this is a supervised image classification problem. It is something like that it is classifying that okay, this is the fake and this is the real. So that is quite simple, I think. Now you can see here, like this is the complete architecture of the discriminator. Like this is the input layer is there, then convolutional 2D layer, leaky ReLU, then dropout, then convolution 2D, then batch normalization, then leaky ReLU, and these all series is going on. Okay, and with that all series, actually we'll be writing the code as per the series. We'll be actually building the layers one by one, two, three, four, something like this layers. Okay, and you can see here the parameters are there and trainable parameters, non-trainable parameters here there. So this is the code. This is the actually code. It is somewhat longer. You can see here. It is quite longer layers. Like it is too much layer, as we have seen in the variational autoencoder. It was somewhat less. Okay. Now it has a lot of. You can see like this thing is repeated here, and yeah, and then again it is repeated. So it is repeated three times, I think. Uh, but with different output shape. Okay. So we'll be seeing all these things. So first thing that what we'll do, we'll just copy paste the code, and I'll be explaining you that what the code is actually doing. Okay, 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 okay. So first thing that this the link of um, this collab notebook will be in the description. Just go and access that link. And one thing is there for you guys. Okay, okay. So what you can do that with this link, you can just go and make a copy of it. Okay, so there will be like save a copy in the drive. You can just click here and you can copy it. Okay. Now I am running it again. Disconnect and delete the runtime, and I'll be running it again. Okay. Let's see and run all. So again, we have to do all the things because we have to download the data set. So let's do it again. So it will actually not download the data in your system. The Google Colab server will download uh, on its own computer. So you just need what you do. We'll be search on the Kaggle. So in the previous videos we have like I will say that please go and watch the previous video in which I have explained in a very detailed way that how can you actually upload it and download the data from the Kaggle. Just see that it is downloading the data from the Kaggle. Okay. Although this speed is quite slow, in respective of the previous we have seen. Okay, it seems that there will be load. So you can see here. Okay, so I am just pasting the code, and this is the code. Okay, you can write it one by one. Okay, because so that you'll have the more clarity that what the code is actually telling you. So let's zoom it. You can see here the discriminator input is there. So input layer is there. Okay. Then there is a convolutional 2D layer. Then leaky ReLU layer is there. Then dropout layer. Then convolutional 2D layer. Then batch normalization is there. Then this all things are getting repeated. Just see this thing. One time, two time, and three time. It is getting repeated. And then it is repeated. After that, there is a convolutional 2D. And after that, you can see here, it is the flattened layer. At the last, there is a flattened layer. You can see here. Here is the flattened layer. And now you can just get your model. Okay. So in a model, you can get it. Okay. 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 Hmm. So we can just paste it. So this will be to you. So you can just copy the path. You can just see the previous video. I will give it the link. Okay. So no need to worry. And I think I have to paste it. And let's see. Okay. 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 In the data set, just open. So it has actually downloaded the data from the train. There is the data set. Okay. It is not opening. Okay, please open. So let's see again because it is giving error. Okay. Yeah, okay. So this was the whole data, whole thing was there. S- Oh, so you will get this code. Okay. So no need to worry. I'll be just quickly pasting it and I will just take the dataset link. So I will copy path and I will just paste it here and yeah, we are good to go. Let's see if there is any error or not. Okay. So uterus is not defined, so we'll be explaining the error and we'll be seeing that what is the issue. So I think in previous video I have edited, but maybe it was not saved. That's why it is giving okay. This is okay. This I have forgot to delete it. Just run this thing. Okay. And you are good to go. Yeah. So this was the whole thing. So now you can see here the discriminator thing. Okay. Now you can see here it has defined the every layer, and after that, okay, models is not defined. So I think this model can be defined from the TensorFlow itself. So actually, we are taking the TensorFlow library and we are using it. Okay. Now let's see. Let's see. This is taking some time till we can see here. This is the whole architecture of the discriminator. So okay. So what we'll do, we'll just copy it and we'll be running it and it will be doing our task in a very easy way. Although, okay, so we have to import the models. So let's see that how what is happening actually. Maybe it is not taking the. Okay, let's put this into ChatGPT and let's see the error actually. What happened? So this is now white ChatGPT. So yeah, okay. I was thinking that this was the error actually. You can just go and so so you'll be not facing this error actually because I'm giving you the whole notebook, so you don't need. Although some errors will be, of course, there when maybe you'll be watching this 1 year after 1 year or something like that, then maybe you can get error. But like library change and all these things, so it can be error. But yeah, you should be able to see the thing that Chat GPT just put on the Chat GPT, ask that what is the reason behind it and what is the good code is there. Okay, so define the input layer of the discriminator. Okay. So we have defined the input layer. Yeah, you can say here, um, you can see here, this is the input layer. And after that, we have the 2D layers, batch normalization, leaky ReLU. And what this thing does actually, what the batch normalization does, leaky ReLU activation does, and report layer does. You just, I will say that please search it. Okay. Please search and write in the comment that what does it mean. Okay, because it is quite easy. And if you are not getting that what is this thing, then please comment that below. I'll be taking one session and I'll be explaining this thing to you. Then you can notice that how you use the stride of 2 in some convolutional 2D layers to reduce the spatial shape of the tensor as it passes through the network. Then finally, while increasing the number of channels in the one grayscale and before classical prediction. So what it is actually doing, I'm just giving you an overview that it is actually we are using the stride of 2 in some convolutional 2D layers to reduce the spatial shape of the tensor. So we are actually decreasing the shape of the tensor so that I think it will actually decrease the size and the computation. So let's see that what does it mean. What does it mean? So, guys, I have told you that I'm getting very less time so that I can study and again teach. So that's why I'm studying, and you can just follow with me. So that's why I'm searching things. It is okay to search. Okay. So what are they saying? Give me a summary that it is downsampling the spatial dimensions of the input image while increasing the number of the channel and finally applying the sigmoid functions to obtain a probability. Why you are doing this? We are just copying why it is doing this. So you have to be like that you can self study the things also with the help of some tutorials. So main thing is that you would put the effort more. The downsampling is the special dimension of the image helps in the capturing the higher level features in the larger receptive fields. So I hope you got the thing. The downsampling the spatial dimensions, width and height of the image helps in the capturing the higher level features. So that is the important thing. Then why we are increasing the number of channel? So we are increasing that the network to learn more complex and abstract features. So that is the two things. And applying the sigmoid functions to find like what the sigmoid function does. Sigma function actually does that it actually does in the classification task that if it is above the zero point 0.5 then this is 1 and something like that. Like if you are classifying that this is fake or real, then it is greater than zero point 0.5, then it is real, then less than zero point 0.5, then it is fake, something like that. Okay. So this was the whole thing about the discriminator. We have coded the discriminator. We have seen that how there is a three layers you can see here. Like batch normalization to convolutional 2D layer is there. Uh, or it is starting from the convolutional 2D, leaky ReLU and dropout. And फिर again, okay. So I think you can see here, like three parts are there. One part is there, second part is there, and third part is there. Like you can see here, this is the third part. Okay, I'm just coloring it. Yeah. So this was the three layers. Now you can see here. This is different layers. Okay, but you can notice the pattern. This is the input layer, and then the flattened layer is output layer. Okay. So this was the actually whole architecture of the discriminator. I hope that you have got some understanding that how discriminator is built up. And if you want to know more about the discriminator, then I will say that just copy it, copy this code like this, and like teach me the architecture of the discriminator. So it will be teaching you in a more and more deeper way. Like if you have any doubts, then you can ask through ChatGPT also, and you can ask in the description also. Okay. So I hope you got the things. Now, what one thing is there for you guys? Like I'm just searching. Okay, LinkedIn, and actually we have made a group for ML to AI. Here you'll be getting the quiz. So attend this quiz. This quiz is quite important that so that it will actually assess that what you are learning in the lecture series. So the link will be in the description. Go and join the group. Okay, guys, join the group and be active here. Post any question that you have, any query you have, and anything you want to share, you can share here related to the generative deep learning. And meet you in the next video. Thank you so much, guys. And if you have any doubt, anything that any suggestions, then please write in the comments.